Hello viewers, in today's session we are going to discuss another problem from integration, and in this session we are going to evaluate this integral, that is 0 to 1 x raised to a minus 1 minus x raised to b minus 1 divided by natural log of x, right? So here we are going to make use of the method of differentiation under the sign of integration, right? So in this method, what we do, we treat any of these two constants, that is a and b, as a variable, right? So here we can select either a or b as a variable, and the rest of the terms may be considered as constants, right? And then we differentiate this integral with respect to the selected variable. So let us call this integral as I, right? And here we select a as a variable, and the other terms may be considered as constants, right? So we'll differentiate partially with respect to a, both sides, right? So here we can now write di over dA. So we'll differentiate this integral I with respect to a. So here we write this operator, that is del over del a, and here we have the integral 0 to 1, and we can write the integrand as x raised to a minus 1 over natural log of x minus x raised to b minus 1 over natural log of x. And here we are treating a as a variable and b and x as a constant. So we'll differentiate this term which is inside the integral sign, that is our integrand, with respect to a. So now taking this operator inside the integral sign, we have now a 0 to 1, and we have del over del a of x raised to a minus 1 over a natural log of x, and the partial derivative of this term with respect to a is 0, because we are differentiating this integrand with respect to a partially, right? And here we have dx, right? So now here 1 over natural log of x may be considered as a constant. So we can now write 0 to 1, 1 over natural log of x, and we have del over del a of x raised to a minus 1, and here we have dx. So now we have a di over dA as this term. So now let us find out the derivative of x raised to a minus 1 with respect to a. So now let us separately find out the derivative here. So we can now write here x raised to a minus 1, and we can write x raised to a minus 1 as e raised to natural log of x raised to a minus 1, because we know this important result, that is e raised to natural log of, say, p is equal to p. So here our p is x raised to a minus 1, right? Okay, so now here we can now apply the properties of log, that is a log of, say, m raised to n is n log m. So here we have a minus 1, so we can take a minus 1 in front of the log notation. So we have a minus 1 and natural log of x, right? So now let us find out the derivative of e raised to a minus 1 natural log of x with respect to a. So we have here e raised to a minus 1 natural log of x, because the derivative of the exponential function is the exponential function itself. And then by chain rule, the derivative of a minus 1 times natural log of x with respect to a is simply a 1 minus 0, and here we have natural log of x because the derivative of a with respect to a is 1 and the derivative of 1 with respect to a being a constant is 0, right? So we have simply here e raised to a minus 1 times natural log of x can be written as simply this term, that is x raised to a minus 1. So we can now write again natural log of x raised to a minus 1, and here we have natural log of x, and this term is simply x raised to a minus 1 times natural log of x. So now we can write here 0 to 1, 1 over a natural log of x, and the derivative of x raised to a minus 1 with respect to a is given by x raised to a minus 1 natural log of x, and here we have dx. Now these two terms get cancelled and we have simply 0 to 1, x raised to a minus 1 and dx, right? So now again we can treat x as a variable, and we can use this well-known result, that is integral x raised to n dx is x raised to n plus 1 over n plus 1, right? So here for n we have a minus 1, so we have x raised to a minus 1 plus 1 over a minus 1 plus 1, and the limits of integration are from 0 to 1. So we have now x raised to a, and here we have simply a, and we have the limits from 0 to 1. So now we can substitute the limits and we'll take the difference. So we have now 1 over a. First we'll take x is equal to 1, so this is 1 raised to a is simply 1, and here we take x is equal to 0, so this term is now 0. So we have simply 1 over a, right? So now the derivative of this integral I with respect to a is given by di over dA is equal to 1 over a. Now this is a variable separable form of differential equation, and we can solve this differential equation by a method of separating the variables. So we can now write di is equal to dA over a, and now integrating both sides, and c is the constant of integration. So here we have simply I, and here we have the integral of dA over a is natural log of a, because we know that integral dx over x is natural log of x, right? And here c is the constant of integration. So now we have this condition or this equation where I is equal to natural log of a plus c. Now we have to find the value of this constant of integration by using or by imposing some condition on this integral I. So now let us make use of this condition, that is a is equal to b, and taking a is equal to b in this integral, we have I is equal to 0 to 1, and we have x raised to b minus 1 because we are taking a is equal to b, and here we have x raised to b minus 1 over natural log of x and dx, and now these two terms get cancelled, so here we have 0. So the integrand is now equal to 0, so the value of this integral reduces to 0. So now we have this condition, that is when a is equal to b, then the value of I is equal to 0. So now let us make use of this condition to get the value of c. So here taking a is equal to b, we have now I is equal to 0. So we have I is equal to 0, and that is equal to natural log of b plus c, taking a is equal to b. So now solving this equation, that is 0 is equal to natural log of b plus c, we have c is equal to a negative of natural log of b, right? So the constant of integration c is equal to negative of natural log of b, and substituting this value in this equation, now I is equal to natural log of a minus a natural log of b, and using the laws of logarithms, here we have log of a over b, right? So the value of this integral I is given by a natural log of a over b. So viewers, this is how, by making use of the concept of differentiation under the sign of integration, we can easily find out the values of these kind of integrals.